Hi everyone, welcome back to my channel. Here we have an equation of x cubed ln of x squared, which we're trying to sketch. Now we're going to follow the rules of sketching and find the x and y intercepts, all the asymptotes if there is any. We're also going to find the max and minimums or any point of inflection that this graph might have. First things first, in order to find the y-intercepts of this function, I will use this color. So in order to find the y-intercept, we need to place x as equal to 0. So we will have 0 to the 3 ln of 0. Okay, so we know that this is automatically equal to 0. So at points 0 and 0, we will have an intercept. And then for x-intercept, we want to put y equal to 0. So then we have 0 equal x cubed ln of x squared. So this could have a few possibilities. Now x is definitely going to be 0 for 1. And then ln of x has to equal to 0. Ln of x squared has to equal to 0. So ln of 1 is always equal to 0. Therefore, x could be either plus 1 or minus 1. So we have this, we have this, and we have this. So we have 3 points of intersection, one over here, one at 1 and 0, and one at -1 and 0. Okay, that's the first step. Now the next step is to figure out if there's any maximum or minimums of this graph anywhere here. So in order to do that, we do have to take the derivative of the function and put that equal to 0 and figure out if the slope of this graph changes at any point, and if the slope changes from positive to negative or from negative to positive, we will know that we have a maximum or a minimum for our function at that point. Now let's try to do that. So the first step would be to find y prime. Now since my function here is a product of two functions of x cubed and ln x squared, we are going to use the product rule. Now I will have to take the derivative of the first one, so which is the x cubed here, and in order to do that, I would like to rewrite my equation a little bit more simpler. So I have x cubed, and I know ln of x squared can be rewritten as 2 times ln of x. That is one of your identities for log and lns. So if I have, for example, just to go over this a little bit further, if I have ln of 3 to the 2, I can rewrite that as 2 times ln of 3, and if you punch these two numbers into your calculator, you will get the same number, and it's one of the ln identities that you must have actually done in the beginning of this chapter. So knowing that, I can rearrange this to 2x cubed ln x. It looks a little better. So now if I'm going to take the derivative of this, I will leave the 2 outside, and I will take the derivative of the function here with respect to x. That would be using the product rule. So the derivative of the first one, which is 3x squared, times the second one, so we leave the second function as is, plus the derivative of the second one. The derivative of ln x is 1 over x, so it would be 1 over x, times the first one, and the first function is x cubed. Okay, this looks very simple here, so I will just simplify it as 3x squared ln x, and then over here I have just x squared because these x's cancel out. Perfect. The only thing that is left here, I don't like these two. They are in common, so I'm just going to factor that out. So I'm only left with this. This is my derivative equation. Now, what do I need to do in order to find my max and min? I need to put this equal to 0. So let's go to the next page. Y prime equals to 0. So I have 2x squared, 3 ln x plus 1 equal to 0. Now obviously my x will be 0. And then also from the second part, and then we have 3 ln of x plus 1 equals to 0 as well. So if I were to rearrange this, I will have 3 ln of x equals to -1. And then if I want to solve for x here, I have to divide both sides by 3. Therefore, I will have ln of x equals -1/3. Okay, now how do I solve for x here? I will explain that in a different color. Basically, ln of x, as you know, it means natural log of x. Therefore, if I have ln of x equals to -1/3, I have log e of x also equals to -1/3. And by log rules, you know that x is equal to e to the -1/3. Okay, so that's basically my answer. But if I go back to my function, if I have e equals to, x equals to e to the -1/3, if I have x as -e to the -1/3, I will get the same answer for this function since I have x to the power of 2 here as well. So what I can do, I can go back to my function here and write that my x could be positive or negative e to the -1/3. Okay, now I'd like to actually find out what these points mean. So if I have e to the -1/3, if I punch that into my calculator, so e to the -1/3, it's pretty much 1/cube root of e, and that's equal to 0.716. If I plug that back into my function and have 0.716 to the power of 3 ln of 0.716 to the power of 2, I will get -2.45. Therefore, at 0.716 and -2.45, I will either have a minimum or a maximum. Then how can I actually find out which one it is? I will use my sign chart. So I will have 0.716, and I will give this, let's say if I give it a 0.9, and then I can give it also a 0.2 to kind of find out what happens, right? So in order to do that, I will go back to my y prime equation. So my this is the equation, and I will plug in 2.0.716 3 times ln of 0.7, not 7.6, so we're giving it 0.9. 0.9 times ln of 0.9 plus 1. Obviously, if I give it 0.716, I'll get a 0, right? So ln of that, I should get a number that is positive, so it's bigger than 0. Good. And then I can do the same thing with 0.2. 3 times ln of 0.2 plus 1. You can pause this video and calculate this on your own. And once you come back, you should have a negative number here. So what does it show me? How do I know if it's a minimum or a maximum? I know that over here I have a negative slope. which looks like that, and over here I have a positive slope which looks like that, and they meet at this point, and that just means that this would be a minimum. So this point would be my minimum. So I'm going to go back to my graph and have 0.7. So if this is 0.5, 0.67897 would be here, and then at negative 0.2 over here I will have a minimum. Okay, great. Now this point will repeat as a maximum right over here. Why does it do that? It's because my function is x to the power of 2, and if you actually were to substitute for the function and substitute negative 0.716 to the power of 3 times ln of negative 0.716, another bracket, to the power of 2, another bracket closed, you will get positive 2.45. Therefore, we know that there is another point here as well, and one point here. Okay, great. Now the next thing we're trying to figure out is the concavity. So how does my graph go here? Does it go like this, or does it go like this? Or is there any other concavity point somewhere in the middle here? Okay, how do we find that out? By the second derivative test. So let's do that here. So my y prime function is 2x squared 3 ln x plus 1. So what I'm trying to do is to take the derivative of this guy, and in order to do that I will keep my 2 out, and then I have two functions here, function number 1 and function number 2. So the derivative of the first function is 2x times the second function plus the first function times the derivative of the second function. So the 3 remains, and the derivative of ln of x is just 1 over x, and the derivative of 1 is just 0. So I will close that, and I will leave it as that. I have a few things canceling here. So I have this x and this x going out, and I have an x in common here with this. So what I can do, I can actually have the x taken out and just kind of like expand everything else. So I could have 2x, and then I have, when I get rid of this x, I have another 2 here, so I will have 6 ln x plus 2, and then the x here comes out as well, and I will only have a 3 left. Okay, so I pretty much have 2x, 6 ln of x plus 5, and that's what I have for my second derivative. That can be simplified to 12x ln x plus 10x as well. But I like this one because I can easily put this equal to 0. So in order to put this equal to 0, I will have x equals 0, and I will also have 6 ln of x equals negative 5. In order to solve for x, I need to divide both sides by 6. And since I explained before, again, we can get some more practice here, because ln of x equals natural log of x equals negative 5 over 6. Therefore here x is pretty much equal to e to the negative 5 over 6, which is great. So in this case I will take the positive and negative as well, and I will try to figure out what the concavity will look like here. I have 0.435, and I can plug in 0. So let's positive 0.5 here, and we can also plug in 0.2. So I will plug it into the y prime equation. So I will have 2 times 0.2 times 6 ln of 0.2 plus 5, and that will give me actually a negative number. And if I do 2 times 0.5, again, you can always pause this video and do 0.5 plus 5. In this case, I will get a positive number, meaning that I have concave up and then I have concave down. Now, I like to find this point to be able to do a better sketch, so I have to plug this back into my function, which was y equals x cubed ln of x squared. So if I plug that in for x equals negative 5/6, you can pause this video and try to find out what that is. I did calculate that, and I got, so e to the negative 5/6 is pretty much 0.435. It's at negative 0.137. Okay, so I have these, and I can go back to my graph here. So I know that at 0.4 and then at negative 1 point, so somewhere here, so before it's concave down, and then after 0.45 it's concave up. So I'm basically going concave, let's see if I can do this, concave down, concave up, and then I go like that, and then you just kind of go up from here. Right, so I don't know if you can see this, but you're pretty much concave down, up like that. And the same thing mirrors here. So at 0.4, you're concaved up, and then you go concave down, and then you go kind of down like that. And this concludes the graphing of the function. If you have any questions, please comment them down below. Please make sure you subscribe, like, and follow to motivate me to make more videos for you. Thank you. Bye.